Greetings, greetings, greetings. Welcome to week 6. Seeing home stretch. Uh, this is CSC550 Data Communications and Computer Networks. Week 6, we'll be talking about network services and advanced routing concepts. We will be looking at the high level. Being that this is the last week before that you'll be doing your last homework quiz, project. Next week is be totally dedicated to the project. I will be sending the requirements for the project out when I send out the information for week 6, as far as, getting everything ready. So you'll have the project early. Then when it we're going to be taking a high level look at in week 6, we're going to be looking at network services. We're identifying the services that we're going to need and what they do. Okay, we're not going to be doing a deep dive into knowing piece by piece how each one is put together. But just you'll know at the end of this week, when you see the term DNS, okay, it's going to be, the domain name server or system, the domain name system. Okay, so at a high level, look at the information here. We're going to pull out some important pieces from each, and then we're going to take that information and put it in our knapsack of knowledge, that when we hear that term, we'll have a pretty clear understanding of what's happening. Okay, so network services overview, the key terms we're looking at here is, you will hear terms DNS, domain name server, DHCP, NAT, web services, email services, file transfer. Many of these you probably are already familiar with, but some of you may not. Okay, so just for others, just let's make it a little review. DNS, domain name system, translates domain names into IP addresses. DHCP, Dynamic Host Configuration Protocol, is a method where automatically IP addresses are assigned and network is configured. So once I add my iPhone, okay, to the network, with DHCP, basically we're going to automatically assign a IP address. Okay, I don't have to do anything special, so that's done automatically. So that assignment of the node to the IP address, okay, is done for us. So that's basically what we're talking about there. NAT, network address translation. We talked about having private IP addresses previously. It was like week 4. So with this is saying, okay, well, if I'm using a private IP address internally within the LAN, okay, but I need to go outside of the LAN, then I'm going to need a physical IP address. So what this process basically does is take that logical IP address and basically maps it to a physical IP address that we can use to pass information. And the way it does it such that it won't be a 1-for-1 where I have a private IP address that automatically gets transferred to a physical IP address. These particular physical IP addresses are reused based on the immediate need of having a physical IP address, which what I mean is that if I have 3 private IP addresses, okay, and only one of them is active, then I only need 1 single physical IP address. Okay, I don't need 3. So as my need for the physical IP address starts to come, then that is when I'm going to take and go run through the process of physically getting it. So this is going to cut down on the number of physical IP addresses I need. Okay, so here we got NAT, okay, web services, HTTP and HTTPS provides web content and application over the internet, email servers, SMTP, POPs, IMAP, okay, all you have to do with email. Some of you are probably familiar with these terms. File transfer, FTP, SFTP, security FTP, allows secure transfer between hosts. Okay, here, kind of review on a high level, what are the primary functions of each? What's the key benefit? And at a high level, again, I want you to understand that not to the point that we know specifically how a DNS works, but to the point that everything, and we'll see here in the next slide, everything is given a name. Okay, so it's easier to work with names than it is with IP addresses. Okay, so this is basically saying I'm giving you the general overall description or definition. Okay, use that information as far as getting a good idea of what's happening with DNS and DHCP and NAT and web and in email and FTP. Okay, so looking at DNS domain name system, in specifics, DNS is a hierarchical distributed database that translates human readable domain names into IP addresses. Okay, that's what it does. Okay, so I have in this particular example, I have www.example.com. That is the name, okay, that I'm basically going to be going to. And so what I'm going to be doing is converting that name to an IP address. So that's the process of DNS, to take that name that we know internally, that we keep track of, okay, and take that and put it to an IP address. So here lists how DNS works. Okay, here are the ingredients, and fat fingered it as usual. Okay, but again, the key thing here is the process of taking those internal names that we know and basically changing those to IP addresses to where we can basically start them down the network. THCP, Dynamic Host Configuration Protocol. DHCP automatically assigns IP addresses and other configuration settings. Okay, so we kind of talked about this a little bit. The key thing is automatically. Okay, automatically. That's what we're basically harping on, that when something gets added to the network, okay, whether that's a printer, whether that's a computer, whether that's iPhone, iPad, whenever that happens, we want to be able to directly assign an IP address to that. This again, assuming that we're not going through private IP addresses and setting up anything kind of weird. Okay, we're just straightforward. I add a device onto the network. That device now has an IP address. Okay, so that's what we're basically describing here. Information provided by HTTP. So when I do that automatic assignment, this information, IP address is sent, the subnet mask, the default gateway, the DNS server address, the lease time, domain name, and other options. So all this information is the automatic setup is what's going to be sent to, it's being sent to you as far as relating that to a given device that has been added to the network. Okay, NAT, network address translation. It allows for multiple private IP addresses to share public. Okay, we just talked about that. Okay, and that we don't have to have a one-for-one, which makes it very good. Okay, and it's automatic. Static NAT. Okay, you don't have to worry about mapping one-to-one private address. We physically don't have to do it. Okay, dynamic NAT. That's automatically through the process. Okay, review how it works, internal hosts. Okay, NAT device replaces the private. Response from the internet. NAT takes the private and makes it, assigns it back it takes the public, which is coming in from the internet, it automatically assigns it to the private. So that whole cycle here defines as how the NAT works. Understand that. Yeah, key thing, it is basically taking the names, okay, and taking the private addresses and converting them into public addresses and vice versa. Okay, route summarization. This is basically route summarization, also called aggregation, combines multiple specific routes into a single summary route, reducing. This mostly applies to subnets. Remember we said we do a subnet with part of its IT, part of its HR. Okay, those are subnets. Okay, that we can use. Okay. But what summarization, it says, okay, yeah, we have IT, we have HR, we have like ACAAP, we have the medical. So we have all these sections, but in reality, as far as looking at the whole picture, okay, they all are going to the company. Okay. So rather than having all these particular subnets, okay, having their own IP addresses, we can combine it. We can combine all that one into a single route. And that's what's happening here is looking at, I don't have to have a entry in my routing table for each one of those IP addresses that are in the subnets. I summarize those. And so that when I send things out, they all go out as one particular summarized IP address. And then when it comes back, then we take it to and send it to the location that actually needs the information. So that's what's happening in route summarization. Route distribution ensures that routing information is shared between routers and that everything that's needed in order for that route to be used is there. Okay, so that's a basic verification. Routing protocol updates, routes are exchanged between routers running on the same protocol. Route redistribution, routes are shared between different routing protocols using redistribution. Route filtering, control which routes are advertised using filters. Okay. All this is basically saying is that, that this information is shared between routers. So this is the information that everything that's available from my router is going to the next router as far as when we're going to be updating those router tables. Here, general tasks takeaway, proper route distribution ensures that all parts of the network have information they need to communicate effectively. Okay. When I do that distribution, I make sure everything that I need is there. Administrative distance is the trust value that helps routers prefer routes. Okay. So, basically saying if I have two routers, and router A and router B. And so router B sends a route to router A. And router A wants to say, are you sure that that's the shortest path? That's where administrative distance comes in, the trust, priority, and route selection. This is, again, the router here. Again, administrative distance helps the routers to choose the best route source based on trust, not speed. So if I trust this router that this is the shortest path, that's what I'm going to use, even though I have experienced that whenever my router talks to router D over here, they get it twice as fast, but it's not as accurate. Okay. So that's what administrative distance is. It's basically making sure that what we're passing on, that we trust the information being passed. And when we trust the information being passed, that makes it more conducive. Remember, we talked about convergence, where everybody agrees this is the shortest path. Okay, that's what administrative distance is. It enables that conversion can happen more smoothly. Okay, network troubleshooting. Things are going to go wrong. I'm going to try to send something and it's not going, and it doesn't get to where I wanted to go. The things here, the most common, the ones you can identify with here is look at the troubleshooting process. What are the steps that we go through? But more commonly, what are some of the tools that are common? In fact, I'm pretty sure that you're actually doing some of this in the lab assignments that we're working on. But pinging, okay, test connectivity between devices. I'm going to ping this device to see if it's connected. Okay, I'm going to ping this printer to see if it's connected. Okay, so we got pinging, we got trace route. Okay, trace the path packets take to the destination. I'm going A to B. Okay, I have a 3-hop. Trace route says trace where I went. Did I go A 3 hops B, or did I go somewhere else? Okay, so that's the trace route. Basically traces that path of where your packet went. Show IP route displays the routing table. What are the entries in the routing table that you selected from? Show interfaces, check interface status and statistics, debug IP protocol, monitor routing protocol activity. So any time that this IP address is used somewhere, I'm going to get some information passed back to me to say, oh, your IP address is here. Okay, it was here, and then it went here. Okay. So basically looking from an IP address level, tracking that IP address. Okay. So again, I want you to look at this as a high level as far as for your homework. Okay, should be able to get it done pretty easily. There will be no quiz, okay, because after this class, next class will be totally dedicated to the presentation. So still, I'm expecting you to read it. I'm expecting the video, look at the video, and that when we discuss it on Thursday, you will already be somewhat knowledgeable. But it's been great. You know, some of you I may not see in person until after next week. So I want you to know that I enjoyed it and looking forward to seeing you successful and hopefully maybe taking a few more classes under me. Okay, with that, so we're going to shut down week 6. Everybody have a good one. Great semester. Bye.